Welcome back to WAPC. Right now, we are going to discuss about the previous year questions of Kcet. We'll straight away forward to the questions. My first question, in the detection of group 2 radicals, the salt containing chloride is treated with concentrated sulfuric acid and a colorless gas is liberated. The name of the gas is, okay, you have to be, there is a group 2 radical, which means it's an alkaline earth metals. Am I right? Yes. So here it is then treated with concentrated sulfuric acid. Okay, we'll name that with M, something like chloride, such an M chloride, and treated with concentrated sulfuric acid. Okay, we get MHSO4 with HCl. Okay, this is the reason. Okay, so name the colorless gas that is liberated. So the correct gas should be hydrogen chloride gas. Any alkaline earth metals or alkali metal, when treated with the sulfuric acid, only the HCl, hydrogen chloride gas, is liberated. So the correct option for this question would be option A, hydrogen chloride gas. Okay, hydrogen chloride gas is the correct answer. Moving on to the second one. Which is the most suitable reagent for the following conversion? Okay, we do have a ketone. When treated with something unknown reagent, we get carboxylic acid. It is the conversion of a ketone to carboxylic acid. So here we must try the four options. Tollens reagent. Unfortunately, tollens reagent is something that we have to determine whether to distinguish between an aldehyde and ketone. So tollens reagent is not the option, and benzoyl peroxide, we do not use such reagents in the conversion of a carbonyl compound to a carboxylic acid. So benzoyl peroxide is not the correct answer. And we do have iodine with an NaOH solution, alkali solution. We have discussed this question earlier, somewhere around. In the this question has been repeated for a few times. Okay, so try to concentrate on that particular subject or particular topic. Okay, so here we have iodine and an alkali solution with subsequent acidification. So we can try that out. When a ketone RC double bond O CH3, when treated with an halogen like I2 with sodium hydroxide, we get RC double bond O, where we get an oxide of the alkali with trimethyl iodide. Okay, CHI3. Sorry, CHI3. This is trimethyl iodide. Okay, and along with that, what do we get? Na. Okay. NaI, oh yes, 2I2 plus NaI. So this is the reaction. What is the name of this reaction? We have earlier studied that when a methyl ketone, carbonyl compound containing a methyl group adjacent to this carbon is called a methyl ketone. Whenever a methyl ketone is present, we have to treat it with an iodine or along with the sodium hydroxide like alkali to form carboxylic acid. So this reaction is namely haloform reaction. Okay, this is the second time I have seen this question around the past 5 years. So this might be the main subject. Okay, so this is haloform reaction in which we have used iodine. So it is an iodoform reaction. Okay, iodoform reaction. Okay, so the correct option would be option number C. Am I right? Yes, it's C. And we do not use tin and sodium hydroxide in any of the conversion of ketone to carboxylic acid. So the option 10, so for question number 10, option would be C, iodine and an NaOH solution. Okay, we will move on to the next question. The Kh value, which means Henry's constant of argon. Okay, we'll note down the given statements, right? For argon we have how much? 1.83 into 10 raised to minus 5. Oh, sorry. We have for argon we have 40.3. Okay. And carbon dioxide we have carbon dioxide 167 K bar. Formaldehyde HCHO we have 1.83 into 10 raised to minus 5. And for methane we do have how much? 0.413. Okay. These are the values of Henry's constant in the given gases. So formaldehyde and methane. So we have to find out the increasing order of their solubility. Okay. So we do know that Henry's law is given by pressure is directly proportional to the mole fraction. Okay. Solubility which is directly proportional to mole fraction, right? Okay. Where P is directly proportional is equal to Kh Chi A. Okay. You have known this. When Chi A is increased, Kh is decreased. It is inversely proportional. Okay. It is given by this, like Chi A is inversely proportional to the value of Kh. Okay. So by this we could say that the least number of the possible values of Kh has the highest solubility. Okay. So we could here which one has the lowest one? I think it's methane gas with a 0.413, right? Question number 26. Least of the solubility, and more is the Kh, less the solubility. So solubility will be lesser in carbon dioxide, which is 2. Okay, carbon dioxide is less than 2. Option number A. One has the least one, which is argon. Then we have carbon dioxide, then methane, and lastly what? Formaldehyde, right? 1, 2, 4 and 3. Okay, this is the decreasing or increasing order of their solubility. Okay, moving on to our next question. Arrange benzene, normal hexane and ethane in decreasing order of their acidic behavior. We can write this our given compounds. Okay, the given compounds are a benzene ring. Okay, we do know that benzene is C6H6. Okay, we have our benzene ring and normal hexane. Okay, normal hexane without the double bond, and ethane. Yes, this is our ethane. CH. Okay, ethane, and in decreasing order of their acidic behavior, we have to show that the acidic behavior of each of this. So in this benzene ring, we have an sp2 hybridized carbon, right? sp2 hybridized carbon. In case of a normal hexane, sorry, it's a normal hexane, right? So sorry, I'm really sorry about that. It's a normal hexane. We should write this C. Normal hexane, right? Okay. A normal hexane has sp3 hybridization. Okay, sp3 in normal hexane. Okay, normal hexane has sp3 hybridization, and ethane has sp hybridization in each of their carbon atoms. Okay. Okay. So we have to find out the acidic character. When S character increases, their electronegativity also increases. Okay, that's the fact that we have to check. Both the electronegativity and the S character are completely proportional. So when S character is higher in sp hybridization than that of sp2 hybridization, and to that of sp3 hybridization. So in case of what is the correlation between electronegativity and acidic character? Ease of removing of electrons or the atom from the compound there is nothing but the electronegativity. So it increases the acidic character. Higher the electronegativity, it is also the higher acidic character. So here higher electronegativity, which means greater the S character. Okay, S character, greater electronegativity. So ethane has the highest S character, which means it has the highest electronegativity and highest acidic character. And to that we have benzene, which have sp2 hybridization, which have lesser S character than ethane and more S character than normal hexane. So benzene comes in second, and in third we have normal hexane with sp3 character, sp3 hybridization and lowest S character. So the option would be ethane, benzene and normal hexane, which is option number D. Okay, did you get that? This is option number D. Okay, moving on to our next question. A colloidal solution is subjected to an electric field that colloidal particles move towards, move towards anode. The amount of electrolytes of Ba, barium chloride, aluminum chloride and sodium chloride required to coagulate the given colloids is in the order. Okay, you have to find out the amount of electrolytes that required to coagulate towards the given. So the coagulation value, okay, the coagulation value for this one is directly proportional, inversely proportional to coagulating power. Okay, coagulating, one second, the coagulating value is inversely proportional to coagulating power. Okay, you have to find out this power. Do you get that? Okay, when as ions are moving towards the anode, that is negatively charged colloid, we have NaCl has +1 character and more the then Ba2 plus and Al3 plus. So the equation would be, so the correct option would be sodium chloride with the highest coagulation value and then with barium and then with aluminum. So that the option would be option number A. Am I right? Yes, that's the right answer for that. You have to prove that coagulating value is inversely proportional to the coagulating power. Okay, moving on to our next question. Consider the following electrodes. Okay, this is actually about the concentration of every zinc atoms in present. Okay, so 28th one. Okay, you have to find out the electronic volts in each one. So we have to find out Zn2 plus. When Zn2 plus is treated with 2 electrons, we get Zn. Okay, E reduction of this reaction is equal to E0 reduction minus 0.059 by N. Okay, log 1 by Zn2 plus. So hereby we could say that the E reduction for this reaction would be minus 0.76 minus 0.059 by N into log Zn2 plus. Okay, we do know that, and by giving this we could have this one by inversely proportionality. Okay, log 1 by Zn2 plus is given by positive log Zn2 plus. Okay, we have converted like this one, and we could say that reduction potential of this reaction is directly proportional to the concentration of Zn2 plus. More the concentration of Zn2 plus will be the more reduction potential. So we have to find out the electrode potential of the above electrodes. Okay, for this we have greater in Q, then with R, okay, lesser than R, then we have third in S, then lastly with the P. So Q has the highest electrode potential with 0.1 molar of the Zn solution, again with the R at 0.01 molar solution, and with the S 0.001 molar solution, and with the P 0.0001 molar solution. So the correct option would be option number C, isn't it? Yes. Moving on to the next question. Okay, we have, yes, when the absolute temperature of an ideal gas is doubled and the pressure is halved, the volume of gas would be. That's our question. Okay, will be the half of original value, will be 4 times of the original value, 2 times, or 1/4 of the times. Okay, we'll just look after this one. Our question is PV is equal to nRT, right? When absolute temperature of an ideal gas, this is our ideal gas, when we'll convert that to the in variables. P, V and T are variables equal to nR. Okay, we have done this one, and we could take out the second gas which has the pressure halved and volume is doubled. We could write that as P2 V2. Okay, this is the ideal first solution. P1 V1 by T1 is equal to P2 V2 by T2. Okay, are you familiar with this one? No doubts. Okay, then we have, what did we do? Doubled temperature is doubled. Okay, we have T2T. So P into V1 is equal to T is equal to P by 2 into V2 by 2T. We have doubled the temperature and half the volume. Am I right? That's what we did, right? Yes. So the pressure is halved, right? Pressure is halved. Okay. Pressure is halved. Only the variable thing is V1 and V2. Okay, that we have done, and we'll cancel out each other. 2T, P and P is cut, T and T is cut. V1 is equal to V2 by 4, which is V2 is equal to 4V1. Okay, sorry, 4V1. Okay, so the correct option would be volume is 4 times that of original volume. Okay, 49th is option number B, which is, we have found out that the original volume has 4 times that of initial volume. Okay, moving on to the next question. Okay, 49th. Yes, the correct order of wavelengths of light absorbed in the complex ion. That's what our question is. Okay, in COCl NH3 5 times, hexamine cobalt and hexacyano cobalt. Okay, these are our compounds. We have to find out the order of their wavelengths of light absorbed. Okay, this is our wavelength of the light absorbed is inversely proportional to the strength of the ligand. We always know that. Okay, more the stronger the ligand, it will be lesser the absorption of light. So what are the strongest ligand here? We have cyanide ion is the strongest ligand upon here comparing to ammonia. So we can have that cyanide as the least. Okay, cyanide has the least. Okay, comes like this one, COCN6 3 minus is the least one. Yes. What about the second? Well, chlorine is much stronger than, it's a little bit stronger than ammonia. Rather, comparing to a neutral ligand, chlorine is much. higher. So the presence of a chlorine atom in the 6 coordination number of cobalt gives a much more stronger ligand. So COCl NH3 5 is, oh sorry, I have written that in. Okay. And first would be COCl NH3 5 3 plus, okay, and comes the CONH3 6 times, okay, NH3 6 times, then lastly COCN6 minus, okay. These are the strengths of their ligands and the remaining absorption of wavelength. COCl cobalt pentamine chloro cobalt has the highest absorption of wavelength, okay. So the option would be option number A, 55 question number, option number A. Okay, we will move on to our next question. The rate of gaseous reactions is given by the expression K, a concentration of A into concentration of B raised to 2. If the volume of vessel is reduced to 1/2 of the initial volume, the reaction rate is compared to original rate is. This is our question, okay. We have given that the rate expression of the gaseous reaction, okay. With that we have to find out the reaction rate as compared to the original volume, okay. So the rate of the reaction would be rate is equal to K A1 B2, right? Yes. With that we could say that the volume of the vessel is reduced. What about the concentration actually? Concentration we can write like this one, right? N by V into N by V of B, right? Na by B, 1 and 2. Yes, this is our concept, okay. If the volume of the vessel is reduced to 1/2 of the initial volume, so we have to reduce the volume of V of A and V of B, okay. We can reduce that. Rate is equal to K into N by V by 2, okay, V by 2. We have reduced that of A and we have reduced that of B. Yes, we have reduced both the volume of each concentration, and with that we could also say that rate is equal to E by 2, which goes on up, gives 2N by V, 2N by V, 2N by V, 8K. Am I right? Volume is reduced, okay. So volume of vessel is reduced to 1/2 of the initial volume. Initial volume, yes, we have V by 2. We have reduced it to, yes. So that N by V into 2, okay. Then N by V into 4, 2 square 4, which comes rate is equal to N by VA into N by VB into 8. So that the initial rate of the reaction is 8 times greater than that of the second time, which is half. So the correct option would be option C, 8 times more than that of the initial rate of the gaseous reaction. Okay, we will move on to our next question. Yes, the product A gives white precipitate. Okay, we do have 2 aromatic compounds here and an oxygen. Okay, this is our reaction. Okay, the product A gives white precipitate when treated with bromine water. Yes, what is our bromine water? What might be the white precipitate? The product B is treated with barium hydroxide to give the product C. The compound C is heated strongly to form product D. The product D is, they are asking what is product D. Okay, we do know that A is phenol, you know, because when A is treated with like and A is treated with, phenol is treated with bromine, A gives a white precipitate when treated with bromine water. Yes. A is phenol. We do know that in this reaction we could state that the reaction is a phenol formation reaction. Yes, we have found phenol at A, and when this A is treated with bromine water, okay, orthobromophenol, which is a white precipitate is soluble in soluble, and the product B should be something like acetone. Am I right with an acetone actually? Yes, product B, acetone, gives acetone. Okay, product B gives acetone, which is barium hydroxide. When it is treated with barium hydroxide, sorry, plus, okay, let me write this equation completely from here. Okay, we get B is equal to an acetone, CH3, C double bond O, CH3. Okay, when treated with B is treated with our barium hydroxide. Okay, barium hydroxide. Yes, this is actually a classic example of a aldol condensation reaction, which is other than followed by heating gives to form a 4-methyl penta 3-on 2-on. This is actually right. Yes, 4-methyl penta 3-on. Okay, 2-on. Aldol condensation reaction. Okay, we'll move on to our next question. A reaction A plus 2B products, when concentration of B alone is increased, half-life remains the same. If the concentration of A alone is doubled, the rate remains the same. The unit of the rate constant reaction is, as we have discussed this question earlier in the previous chapter, previous question paper. This is actually something where rate of the reaction is actually discussed along and along. So chemical kinetics is an important chapter, and more of the questions are from chemical kinetics. So let me look at this one. A reaction from A plus 2B gives a products. When a concentration of B alone is increased, half-life remains the same. A reaction in which it does not depend upon the concentration of the initial concentration of the reactants is actually much the first order reaction. Okay, this is the first order reaction when rate of the reaction does not depend upon the concentration of initial concentration of the reactants. So first order unit of first order reaction is second inverse. We have discussed that earlier about finding the units of reactions, and it is second inverse. Okay, we'll just move on to our next question. When a dihydrogen is treated with sodium chloride, okay, I think we have discussed this question before. We'll move on to the next one. What is the following? Which of one of the following is correct for all elements? So from scandium to copper. Yes, D block elements, scandium to copper. Okay, the lowest oxidation state is shown by them is +2. Is this correct? Can you name anything that for all elements? We could say that there is also a +1 oxidation state from everything. Scandium, vanadium, and titanium does have +1 oxidation state. So A is wrong. Forest orbital is completely filled in the ground state. Well, this is also wrong. Both copper and chromium has half filled forest state. Okay, we could cancel out that one. 3D orbitals is not completely filled in the ground state. That is also wrong. There are completely filled state from both in the scandium to copper. The ions in +2 oxidation states are paramagnetic. Well, it might be true actually. Every scandium to copper at iron, copper, nickel, cobalt, nickel, copper. Okay, we have done this one. Ions in the plus 2 oxidation states. Scandium does have a paramagnetic structure. Okay. Titanium has paramagnetic. Vanadium has paramagnetic. Chromium has plus 2 in oxidation state does have a. Manganese also have a. Iron does have. And basically the ions in the plus 2 oxidation state are paramagnetic. So the correct option would be option D. Okay. Let's move on to our next question. Which one of the following compounds on heating gives N2O? Okay, N2O, not NO2, N2O. If it is a nitrogen dioxide, you could say that it's easily lead nitrate. Okay, only P block elements give such nitrogen dioxide. So what will be the answer at here? Actually, here we do not give, lead nitrate does not give, sodium nitrate does not give nitrogen dioxide. The correct option would be option number B, NH4NO3. This upon heating gives N2O. Okay, this is the correct reaction for this reaction. Okay, moving on to the next one. Peroxide effect is observed in the addition of HBr but not with the addition of HI to the unsymmetrical alkane because you know Karash's effect or peroxide effect. Have you studied about that one? Yes, this is actually, but the HI bond is weaker than that of the HBr bond, so that iodine free radicals combine to form iodine molecules. Okay, so there cannot be observed in HI. We have to the peroxide, when a peroxide is added to a unsymmetrical alkene, okay, the HI bond is much weaker, so that HI bond breaks easily than that of the HBr, so that the iodine free radicals comes out and forms an iodine molecule, I2 molecule. So the correct option would be option B. Okay,